at the beginning of the year you were introduced to exponential variables and how to multiply with exponents. You had x squared times x to the third, and you learned that it was x to the fifth. Now we are going to calculate values of exponents when we have numbers as a base. We have been going to Desmos using the scientific calculator. If you type in desmos.com and you come to Math Tools, you'll get a scientific calculator. You're going to have to rely on a calculator to calculate exponential values. And this button is for when you square it. This button is for when the exponent is something other than 2. The first part of it, you're going to calculate the approximate value of each expression to the nearest hundredth. So I type in, this is for your x squared values. This is for your number squared. This is for your value, whatever you that's not a 2. So I'm going to do this one again. I'm going to do 4 to the 1.7. And I'm going to notice that it's this value, hundredths, that 5 would become a 6 because of that 6, so your answer would be 10.56. If you were going to do 10 to the negative 0.5, it would be 0.32 due to the fact that the 6 causes the 1 to increase. The next one, make sure your parentheses are your friends. I'm going to do 2 divided by 3, and I'm going to close out this parenthesis and then raise it to the negative 1.2, and my answer would be 1.63. Parentheses are always your friend when calculating exponents correctly. Do 4 times 3 to the 0.7, and that is 8.63. So that is calculating the values of exponents. The next thing we're going to do is we are going to graph each function. Now I'm going to graph some exponential functions, and so I'm going to do y equals 4 to the x, y equals 4, and I'm going to then go to the x, and I'm going to show you as I zoom in that this graph, and I'm going to zoom out, it looks like this funky, it starts here and then shoots up pretty quick. And I'm going to show you some things that this line, if you zoom in, never touches the x-axis. And that's called an asymptote, which is a line that a curve approaches but never touches as it heads towards infinity. They can have horizontal asymptotes, vertical asymptotes, or oblique asymptotes. And then we are going to look at the table. And we're going to notice, this is a great lesson post-COVID, because COVID infections are actually exponential functions. So if I plugged in the values, it would be 0. When I plug in 0, it's 1, because anything raised to the 0 power is 1. 4 to the 1 is 4. 4 squared is 16, etc. Exponential functions have only, asymptotes can be anything, but exponential functions only have a horizontal asymptote. So there is going to be a horizontal line that it never touches. And this one is at x equals 0. And what it is you can never get to 0, no matter what number you plug in. So give you example, if I plug in -76, that is a lot of zeros, and then there's a number. And so no matter how big of a number you plug in, if I plug in 543, oh, calculator's messed up, 558, let's see if it does 200. Yep, that's a whole bunch of zeros, but it's still not at 0. So exponential functions always have asymptotes. Asymptotes are a line that the graph will approach but never hit. And that's the introduction to exponential functions on 15-1.